Hello everybody, I'm Dr. Ayman Noor. I'm here to present you our work titled Breakdown Voltage Test on Green Oils as Alternative to Petroleum Oils for Transformer Insulation Application used in Libyan Distribution Network. This work is the result of the cooperation between me and Mr. Abdurrahman Haiba from the University of Oman Mukhtar and Dr. Mohammed Bara and Dr. Omar Jum'a Mrehel from the University of Tripoli. As outlined, my presentation starts firstly with an introduction, secondly the problem statement, the suggested solution, and the objectives of the research will be present. Thirdly, the research methodology will be described before concluding. The obtained result will be exposed and discussed. According to a technical report published by the electricity operator in Libya, so-called General Electricity Company of Libya, in 2017, the cost of distribution transformer just for 5 years from 2013 to 2017 has exceeded 189 million euro as shown in this table. There are two types of transformer in operating with Libyan distribution network. The first is named bad or ground mounted transformer GM, and the second type is known as pole mounted transformer PM as shown in this table. The number of these transformers per region is given in this figure. Referring to the previous mentioned report, the number of failed ground mounted transformers is 280 annually, while the damaged PM or pole mounted damaged transformer is 2094 units per year. The power transformer is one of the most important constituents of the electrical network with a large quantities and considerable cost. Mineral oils is of common practice for two purposes. The first is the insulation and the second is the heat evacuation or cooling. As shown in this figure, the paper insulation, the winding and the iron core are immersed in the transformer oil to ensure the insulation. The transformer has a conservator to compensate the reduction in oil. In addition, it has a radiator with oil circulating system to cooling the transformer. This slide shows some factors causing transformer failure. The first factor is the heavy loads due to heating in winter and air conditioning in summer. The second factor is the overvoltage in distribution network feeding the transformer during off-peak times. Factor number 3 is the removing of lightning arresters and the arcing harness that cause the line to trip. Factor number 4 is the adding untreated oil to the transformer because the limited number of oil treatment machines available. The last factor is the poor maintenance. There is no a comprehensive plan to check all the existing transformers. As mentioned in the previous slide, the transformer oil is one of the factors that causes the damage of transformer. These oil in general are in contact with many solid materials within the transformer such as paper insulation, metal and iron core, and many impurities can be dissolved in the oil. Moisture and some other hydrocarbon gases are the most common type of these soluble impurities. Under energizing, non-uniform electric fields are set up within the transformer. As a consequence, contaminants in the oil will be subjected to electric force, forming a bridge which increases conduction or initiate breakdown due to excessive electric field. So stresses due to electric, thermal and chemical progressively deteriorate the oil condition with time. In fact, the deterioration of transformer oil affect the health and life of transformers. There are many proposed solutions in the literature. This slide cites some of them. The simplest way is keeping periodic inspection by the electricity operators. Other research studied the mixture of different types of oils in order to obtain high dielectric strength. Latest research proposed adding nanoparticles to the oil for improving its properties. Finally, as environmental friendly solution, researchers suggested the using of green oils. The objectives of work presented here are given in this slide. The first objective is studying other alternative-based plant oils. The second objective is establishing experimental tests on this oil. The last objective is knowing the breakdown voltage for these oils. Our research methodology is detailed here. There are two diagnostic methods. The first is the so-called classic method, like breakdown voltage test, the furan analysis, the frequency response analysis, and the dissolved gas analysis. The second method are the optical methods, such as ultraviolet spectroscopy and nuclear magnetic resonance spectroscopy. Because the procurement of breakdown voltage tester in the laboratories of General Electricity Company of Libya, we adopt a breakdown voltage diagnostic method. The steps imposed by the methodology are: firstly, we collecting commercial available oil samples. Secondly, we adding contaminants and raising the moisture. The third steps is employing the dielectric device available at GCOL. Finally, the obtained result will be recording and analyzing. All of the breakdown voltage experiments presented here were performed at room temperature and normal atmospheric pressure using sinusoidal AC supply. Also, tests were carried out according to the specification stipulated by the GCOL. Each test was repeated 6 times in order to ensure correct reading and recording. This slide shows the effect of contaminants on castor oil sample. Referring to table and figure shown here, it is clear that the insulation strength of castor oil is 50.1 kilovolt average before adding contaminants, and it is considered here as an excellent result. After adding contaminants to a castor sample, the breakdown voltage occurred at low average value of 23.2 kilovolt. The effect of moisture on castor oil is given here. Looking to the table and figure shown below, it is observed that the higher the moisture in the sample, the lower the breakdown voltage. A sample of raw or fresh olive oil was taken and tested in a breakdown voltage tester. We noted that the isolation strength of the olive oil was 16.6 kilovolt due to the presence of impurities and moisture in the crude oil. By heating the oil sample to 100 degrees Celsius, it was observed, as shown in the table and figure below, that the insulation strength became stronger, about 36 kilovolt, due to the evaporation of moisture in the oil and solid impurities, which increased the isolation strength. Here we illustrate the effect of water content on a olive oil sample. As the water content in the oil sample increased, the breakdown voltage decreased. It was observed that the insulation breakdown voltage was 12 kV and 9.8 kV at 1% and 2% moisture concentration respectively. The impact of contaminants on corn oil sample is presented here. Referring to table and figure appear in this slide, we can clearly see that the higher the contaminants in the oil sample, the lower the breakdown voltage. The relationship between moisture and the occurrence of breakdown voltage is exposed in this slide through the table and figure below. The impact of increasing water content in the corn oil sample was dropped off the breakdown voltage. I have now come to the end of my presentation. The following can be concluded. The paper dealt with breakdown voltage experimental tests on vegetable insulating oils for distribution transformer application. The presence of contaminants and water contents in transformer oil reduce the insulating strength. Castor oil is the best in terms of supporting higher breakdown voltage, while corn oil has the lower breakdown voltage. In terms of perspectives, we suggest the realization of a study-based additive nanoparticles to the green oils. Also, a mixture of different oil types may be adapted. Thank you for your listening.